Okay, so let's begin with the lecture. If anyone has any problems, he can raise his hands and then I'll be answering to each of your queries as well. So starting off with the lecture of particulate nature of matter. It's all based on your kinetic theory of particles, how the particles behave when they're in different states of matter, how they behave when they are changing their states from solid to liquid or either from, liquid to solid or solid to gas directly. We'll be discussing each of those states independently as well. So kinetic theory क्या है? When we talk about solids, liquids, or gases, all of their different states are described in terms of kinetic theory. You just don't describe them in terms of their, like we have been studying from science years as well, कि solid, liquid, और gases में क्या differences हैं. Now, in terms of kinetic theory, we are going to be discussing the arrangement of particles kaisa hai in solids, liquids, and gases. How are the attractions between solid, liquid, and gases? How are the movements? How are they arranged? How do they, interact, move with each other as well? So if we talk about solids, solids have strong forces of attraction between particles, where particles are packed very closely together in a fixed and regular pattern. Whereas atoms vibrate only in position, but they cannot change their position or move. Solids also have a fixed volume, fixed shape, and a high density. इनका बहुत एक rigid structure है. They are tightly packed particles. They can't move. They are only vibrating about their fixed position. Whereas when we talk about liquids, liquids have weaker attractive forces than solids, and particles are close together. यहाँ भी close together हैं, but in an irregular, unfixed pattern. We are going to watch all of those different box diagrams and a short video regarding the solid, liquid, and gases as well, because in paper, you might be asked to draw a box diagram showing the arrangement of the particles as well. Particles can move and slide past each other, which is why liquids adopt the shape of the container they are in, and also why they are also able to flow. When we talk about fluids, now, in O levels and iGCSE, you'll come across a term which is fluids. Now, fluids is a term collectively used for liquids as well and for gases as well. When I use the term fluid, liquids are also fluids and gas are also fluid because fluids come from the word flow, the one which can move, the one which can flow. Solids can't flow. Liquids also have a fixed volume but not a fixed shape, and they have a moderate to high density depending on the thickness or the viscosity or the type of liquid we are talking about. Oil, water, honey, they are all forms of liquids, but they all have different densities. Gases, on the other hand, completely negligible intermolecular forces. इनमें कोई interactions हैं ही नहीं है. Because their gas particles are so far apart, they are all in a random movement. Now, this random movement is described by the kinetic particle theory. We are going to be discussing in detail in the upcoming slides कि kinetic particulate theory है क्या. Particles are far apart and they move quickly around 500 meter per second in all the directions. They collide with each other and also with the sides of the container, which is how pressure is created inside a can of gas. Actually, recently, last year's paper, there was a question from this chapter 1 of 5 marks. A 5 marks question was there in last year's exam as well. There and the exam question the house ने कहा था कि how by increasing the temperature of a gas, pressure is exerted. And this marks were 5 marks for this question. अब इसकी sequence क्या थी लिखने की that when the temperature of a gas is increased, the first thing that happens is that the kinetic energy of the particles are increased. And once the kinetic energy of the particles are increased, their velocity is increased. मतलब कि the speed of particles ना velocity हो या speed आप कुछ भी लिख दो, the speed of particles increase. And when the speed of particles increase, आप सोचें कि वो randomly move कर रहे हैं. अभी हमने देखा कि इनमें कोई intermolecular forces तो है नहीं and they are all moving randomly. So when temperature increased, kinetic energy increased, their speeds increase, and hence their number of collisions also increase. They started colliding with each other. अब बजाय ये कि सिर्फ they collide आपस में, they also started colliding with the walls of the container as well. And when force was applied per unit area on the walls of container, that is how pressure is exerted. Because I am hoping most of you are physics student as well. Physics में pressure का एक formula होता है. Force per unit area. Whenever on a certain area, let's say वो area यहाँ पे wall of the container है, एक can of a gas है, एक can के अंदर gas है, उस area के ऊपर जब एक force apply होगी due to increasing temperature, velocity, kinetic energies, तब pressure exert होता है. So that is how we are always expected to solve such a 5 marks question in the same sequence. Plus, gases also don't have any fixed volume. Since there is a lot of space between the particles, gases can be compressed into a much smaller volume, and gases have a lower density as compared to when we look at solids and liquids. And that's when we talk about the three states of matter: it's solid, liquid, and gas. Up again, when we discuss each of these states of matter, you are supposed to know and can be asked a question in the form of a table as well. एक टेबल दिया होगा for solids, liquids and gases where you have to describe them in three terms. तीन ways में you have to differentiate them: arrangement, movement and forces. Remember that arrangement, movement and forces. Volume के terms में भी हम बता सकते हैं, and that can be explained in the arrangement part when you are discussing the volume. किन में से किसका fixed volume है और इनमें से किनका fixed volume नहीं है. Let me show you a short video as well that will help you understand the concept we have just discussed over here as well.
In this video you are going to learn what the three states of matter are, some examples of matter, the characteristic properties of the three states of matter. The three states of matter are solid, liquid and gas. Let us look at solids. An example of a solid is your computer. The properties of solids depend on how the particles in solids are packed. In a solid, the particles are closely packed in fixed positions and cannot move anywhere. So, solids are rigid, cannot be squashed or compressed, have a fixed shape and a fixed volume. They cannot flow. Now let us look at liquids. An example of a liquid is water. Just as with solids, the properties of liquids depend on how the particles in liquids are packed. In a liquid, the particles are again closely packed, but not as closely packed as in solids. So this means the particles in liquids can move around each other. So, liquids are not rigid, but because their particles are closely packed as in solids, they cannot be squashed or compressed. They do not have a fixed shape, but they do have a fixed volume. Beware with that one, as many students think because liquids do not have a fixed shape, they do not have a fixed volume either, but they are wrong. If someone orders a pint of beer, they cannot make it 2 pints by pouring it into different containers. As you know, liquids can flow. Finally, let us look at gases. An example of a gas is helium. This is the gas in party balloons because it is less dense than air and unreactive. Again, as with solids and liquids, the properties of gases depend on how the particles in gases are packed. Unlike solids and liquids, the particles in gases are not closely packed, they are far apart. As a result, gases are not rigid and can be squashed or compressed. They do not have a fixed shape nor fixed volume. They fill the whole space they are in.
All right, so can someone give me a summary and differentiate between solids, liquid, and gases? Anyone? Anas, Mirab, Numan Hassan. All right, you can open up your mic and anyone can differentiate any 3 points that will help in differentiating solids, liquids, and gases. As we discussed, we have to differentiate them in three different ways in terms of their movement, arrangement, and velocities. Okay. All right. Solids are arranged regularly. Yes, I can read the messages in the chat box. It would be better if you open up your mic in the next question as well so we can hear you directly as well. So can you tell me what is meant by melting? What type of state change is melting? Noman? Okay. Yes, got it. So melting is when a solid changes directly into a liquid. For example, ice melting into water. Exactly. From solid to liquid. Yes, I've seen your message. It also requires heat energy, which transforms into kinetic energy, allowing the particles to move. It also occurs at a specific temperature known as the melting point, which is unique to each of the pure solid. Now, when we talk about water, the simplest example, H2O, when it is a solid, it is known as ice. And H2O, when it is a liquid, it is known as water. And H2O, when it's a gas, it is known as steam. And through this example, we can explain solid to liquid is melting. Then liquid to gas is known as boiling. Gas to liquid will be known as condensation. And liquid to solid will be known as freezing. Now remember, when we always go from solids to liquids to gases, there's a gain of heat energy. Heat.
Sorry to interrupt you, Sir Walid. Can you give me 1 second?
Sure, sure.
Yeah, I would recommend all of you students to open up your mics so that you can interact with the tutor if you've got any questions, so he can answer your queries then and there. It would be like very good that if you keep up your mics on so that you can interact with the tutor directly. Because if he would go with the flow in the lecture and he would miss your message, your query would not be addressed. Please keep your mics on mute. Thank you.
Yes, Anas, I have received your message as well. Sir, solids cannot be compressed or squashed and tightly packed. Yes, I can read all of your messages. It's better, as Sir has mentioned, you can open up your mics and interact as well. It's not, it becomes tough to open up the messages in between of the meeting as well. Okay. But your answers are all correct. Good work with that. Anyone else who would like to tell me what's the difference between melting and boiling? Anyone who would like to volunteer? Anas, Maruk, Mirab, Numan.
Yes, sir. In case of boiling, when the atmospheric pressure becomes equal to, no, the vapor pressure of a liquid becomes equal to external atmospheric pressure.
Mhm. All right,
Mm.
that's actually the professional definition as well, and that's a topic that we're going to study at the very end of this chapter, the vapor pressure. But you are absolutely correct. And in simpler terms, what you were trying to say that when vapor pressure becomes equal to the atmospheric pressure or the inside pressure, yes, that is the point that we call as the boiling point. To be very specific as well, and mostly this type of definition we mention in A levels as well. Right now in O levels and iGCSE, we are going to study a bit of vapor pressure. But again, the definition would be requiring heat, gain of heat energy, and that's when liquid would change into gas. The liquid particles, imagine the liquid particles which are once very close together, they're going to gain heat energy and start vibrating more, moving more further, colliding more, and moving start more randomly as well. That is how they change from liquid into a gas. This process also requires heat, which also cause the bubbles of gas to form below the surface of the liquid, allowing for the liquid particles to escape from the surface and within the liquid. It occurs at a very specific temperature, even like melting. Melting, freezing, boiling, these are the three states of matter, and these three state changes that always occur at a very specific temperature. Boiling point, melting point, freezing point. Now, from the same slide, I now remember a question that was there in the last year's paper as well, that differentiate between the terms evaporation and boiling. And the question was of 3 marks, and you have to tell three differences between evaporation and boiling. Can anyone tell me any difference between evaporation and boiling?
Yes, evaporation occurs at all temperatures,
Yes,
while
exactly.
boiling does not.
Evaporation occurs at all temperatures. This is the first difference. And boiling, like we've just talked, it occurs at a specific temperature. Any else? Any other difference? There are a total of three differences. Think. Boiling occurs throughout the liquid. If you try boiling a pot of water in your kitchen right now, it's not just the surface of the water that is boiled, right? It's the whole water. If you leave it for a while, the whole water is boiled. ऐसा तो ये नहीं कि सिर्फ surface boil हो रही है, ठीक है? It's basically happening throughout the liquid. Boiling happens throughout the liquid, whereas evaporation जो होती है, that only occurs at the surface of the liquid. This is the second difference. And surprisingly, according to the marking scheme, there is a third difference as well, which is not written in the book as well. So I would like you all to write it down as well. That bubbles are produced at in boiling. Someone has message evaporation occurs at room temperature, boiling occurs at a certain temperature. Yes, that is also correct, Anas. We have already mentioned that in the first one. रूम टेम्परेचर भी ऑल टेम्परेचर्स के अंदर आ जाता है। एंड बॉइलिंग, यू आर एब्सोल्युटली करेक्ट, इट अकर्स एट अ स्पेसिफिक टेम्परेचर। जैसे इथेनॉल की बात करें, इथेनॉल अकर्स एग्जैक्टली बॉयल करता है 78 डिग्री सेल्सियस पे। वाटर की एग्जांपल ले लें, वाटर एग्जैक्टली 100 डिग्री सेल्सियस बॉयल करेगा। अगर किसी को आपने टेस्ट भी करवाना होता है, ये भी सवाल आ चुके हैं दैट व्हाट इज द फिजिकल टेस्ट फॉर वाटर। तो सबसे अच्छा फिजिकल टेस्ट फॉर वाटर यही होता है, इफ समवन गिव्स यू अ लिक्विड एंड यू वांट टू चेक कि अगर ये प्योर वाटर है, आप जाके बॉयल करो, और अगर बबल्स एग्जैक्ट 100 डिग्री सेल्सियस के ऊपर प्रोड्यूस हो जाते हैं, वाटर इज प्योर। तो कमिंग बैक टू द थर्ड एंड द लास्ट डिफरेंस, विच वाज बबल्स आर प्रोड्यूस्ड इन बॉइलिंग। बॉइलिंग में बबल्स प्रोड्यूस होते हैं, and evaporation में bubbles are not produced. I don't think that this point is mentioned in any book, but it was there in the mark scheme. So the third difference is regarding bubbles. Evaporation में, जैसे evaporation तो हर जगह हो रही है, even if you live, place a ball of water under the sun, ठीक है, अभी बाहर जाके आप एक सूरज के नीचे एक बॉल रख दें, वो थोड़ी देर बाद evaporate हो जाएगा, बबल्स फिर भी प्रोड्यूस नहीं होंगे। सी वाटर है, ग्लेशियर्स हैं, रिवर्स है, वाटर बॉडीज है, दे ऑल evaporate बट विदाउट प्रोड्यूसिंग बबल्स। बॉइलिंग अगर आप जाके अभी करोगे तो बॉइलिंग में तो बबल्स प्रोड्यूस होते हैं, बल्कि बबल्स डू टेल अस दैट एक्चुअली boiling has been completely, the water has completely boiled. So these are the three differences, and this is a 3 mark question, very oftenly asked in your papers as well. So can anyone tell me what is meant by the freezing point? Anyone? What is freezing point? Yes, Mirab, Maruk, Noman, Anas,
Sir,
anyone?
in which liquid convert into solid form?
Can you repeat?
Sir, in which liquid changes its shape into solid?
Exactly, good. It turns from liquid to solid. For example, you're absolutely correct. Water का जो melting point और freezing point दोनों 0 डिग्री सेल्सियस है। In the upcoming lectures and classes हमने 2 types of curves जब discuss करने हैं, heating curve है, cooling curve है, उन दोनों में there's a constant state which is the same for water. अब हमने अभी तक जो पढ़े दो, solid to liquid भी हमने cover किया, and we have also talked about liquid to gas. उन दोनों में एक खास बात ये थी, both of them require an increase in temperature, right? But freezing जो है, it requires a decrease in temperature, क्योंकि पहले particles को एक दूसरे से दूर जाना था। When we talk about moving from solid to liquid and to gas, ठीक है, ये वाला क्या था? This was melting and this was boiling. In both of these states, temperature was being increased, मतलब कि energy was being gained as well, because this is where, according to, now I'll talk about kinetic theory of particles. According to this theory, particles को इस वक्त energy gain करनी थी। क्यों? ये भी सवाल आता है, why? क्यों energy gain? Because they want to move away from each other. सॉलिड्स में टाइटली पैक्ड है, दूर दूर हुए, थोड़ा सा कितने हो गए, लिक्विड बन गए, और एनर्जी टेम्परेचर गेन करेंगे और दूर हो जाएंगे। दे आर मूविंग अवे एज यू गो फ्रॉम सॉलिड्स टू लिक्विड्स टू गैसेस बाय इंक्रीज इन टेम्परेचर। अब क्या है दैट वी आर नाउ चेंजिंग आवर टर्न फ्रॉम लिक्विड टू सॉलिड, अब जा रहे हैं। नाउ फ्रॉम मार्क बाय रेड कलर में आप देखोगे तो यहाँ पे अब टेम्परेचर डिक्रीज हो रहा है, मीनिंग एनर्जी इज बिंग डिक्रीज्ड एज वेल। अब वो पार्टिकल्स जो पहले दूर दूर हो गए थे, नाउ दे आर गोइंग टू लूज एनर्जी, नाउ दे आर गोइंग टू लूज ऑल ऑफ देयर एनर्जी, लूज कर जाएंगे एनर्जी, थक जाएंगे। जब वो सारे पार्टिकल्स थक जाएंगे ना, वो वापस एक दूसरे के करीब आ जाएंगे, एंड दैट्स व्हेन दे कन्वर्ट बैक फ्रॉम लिक्विड्स टू सॉलिड्स, सारे वापस आ जाएंगे अपनी जगह पे। दिस इज हाउ यू आर गोइंग टू एक्सप्लेन स्टेट्स ऑफ मैटर। हमने पहले साइंस क्लास में क्या पढ़ा हुआ, 7th 8th 9th क्लास में वी हैव टॉक्ड अबाउट स्टेट्स ऑफ मैटर इन वेरी सिंपल टर्म्स, कि फ्रीजिंग क्या है, लिक्विड टू सॉलिड, मेल्टिंग क्या है, सॉलिड टू लिक्विड। अब इन टर्म्स ऑफ काइनेटिक थ्योरी आपके सारे आंसर्स ओ लेवल्स में आईजीसीएसई में यही बेस होंगे ऑन काइनेटिक थ्योरी, कि व्हाट इज फ्रीजिंग। फ्रीजिंग वो होता है, इट्स नॉट व्हेन लिक्विड चेंज इनटू सॉलिड, वो तो हम सबको पता है कैसे होती है, बाय अ डिक्रीज इन टेम्परेचर when particles lose energy and they start coming back towards each other, the distances between particles increase, their forces of attraction start to increase again, क्योंकि करीब करीब हो रहे हैं ना, जब वो फ्रीजिंग में वापस करीब आ रहे हैं, देयर फोर्सेस वुड आल्सो इंक्रीज, दे वुड बिकम रेगुलरली अरेंज्ड वंस अगेन एज वेल। जो पहले एक दूसरे दूर गए थे, दे आर नाउ गोइंग टू कम बैक। दिस इज an important point. It requires a significant decrease in temperature or loss of thermal energy, and it occurs at a specific temperature which is unique for each pure substance. Now, in terms of kinetic theory of particles, can someone explain me what is evaporation? I already know that evaporation is when liquid changes into a gas. Other than this, in terms of kinetic theory, what is happening in evaporation? Someone has to tell me the detail. What is happening to the temperature, energy, the movement of particles, the distance between them, and the forces? Who would like to explain me evaporation? Come on, you can do it. Anyone? Yes, Anas, I have read your message as well. Anyone else? Maruk, Mirab, Noman, Sarak. Okay, so if we talk about evaporation in terms of kinetic theory, it happens when water gains enough energy. Yes, Maruk, I have read your message. Good job. ठीक है, बिल्कुल यहाँ तक सही है. Now इसको in terms of kinetic theory in sequence कैसे explain करें? सबसे पहले evaporation है तो आप बोलोगे temperature is increased, which means as Maruk has also told me, energy would be increased. Particles have started to gain energy, right? And when they gain energy, that energy converts into kinetic energy. And most of you might be physics student as well, and you would be studying in your chapter work energy power में कि kinetic energy क्या होती है. You'll study that in physics. Kinetic energy is something whenever something moves, कोई भी चीज जब move कर रही है उसमें kinetic energy होती है, और कोई भी चीज just rest पे होती है, that is potential energy. तो when particles are at rest, they have certain potential energy. बट जैसे ही आप उनको टेम्परेचर दोगे, हीट दोगे, वो एनर्जी गेन करेंगे. All of their potential energy that they had at rest positions will be converted into kinetic energies.
Excuse me.
And when they are converted into kinetic energies, what will happen? उनमें speed आ जाएगी, और उस स्पीड की वजह से क्या होगा? दे वुड स्टार्ट मूविंग अवे फ्रॉम ईच अदर. एक दूसरे से दूर दूर हो जाएंगे. दे वुड स्टार्ट स्प्रेडिंग रैंडमली. Kinetic theory is based on random movement of particles, and that is only happening when there is a absorption of energy, gain of energy. And when they move away from each other, their distances would increase, their forces of attraction would be overcome, क्योंकि all of the forces are going to decrease. जो पहले बहुत करीब करीब particles थे liquid form में, ठीक है, liquid form के अगर आप box diagram देखो, this is how the liquid particles are arranged. और अब वो कैसे हो जाएंगे? Look at this. पहले distances कितने थे particles के दरमियान, and now if you compare the distances, they have increased. Forces भी negligible हो जाएंगे now. There won't be any forces of attraction between the particles. Why? Because evaporation only occurs at surface of the liquids where high energy particles can escape from the liquid surface at lower temperatures, below the boiling point of liquid. The larger the surface area, the warmer the liquid surface of a more quickly than the liquid can evaporate. No heat is required and evaporation occurs over a range of temperatures. Like Anas also mentioned, room temperature के ऊपर भी evaporation हो सकती है. आप अपने अभी कमरे में रख दो. आजकल वैसे जितनी गर्मियां हैं, the hotter the summers are nowadays, if you leave a bowl of water near your window even, it will obviously decrease in level. उसका लेवल वैसे ही डिक्रीज कर जाएगा आफ्टर 2 और 3 आवर्स अगर आप उसको विंडो के करीब रख दोगे, बिकॉज आपका रूम टेम्परेचर भी आजकल 30+ क्रॉस कर जाता है, एंड इट कैन इजीली evaporate एज वेल रादर देन आप बॉईल करो जाके लिक्विड को. तो बॉइलिंग एंड evaporation in terms of kinetic theory is almost the same. The only difference in description ये है कि evaporation occurs on the surface, boiling happens throughout and at a specific temperature. तो after, right after this chapter, हम जब past papers इसके touch करेंगे, I'll always move on to the next chapter जब हम इसके topical past papers करेंगे. Whenever we are going to finish one chapter, we will do all of its topical past papers, and then we'll move on to the chapter 2 only when all of you, each and every one of you, is confident enough to move on to the next chapter. Then we have condensation. Condensation is also the opposite of what? Boiling. Exact opposite of boiling. If boiling was liquid to gas, condensation is going to be the opposite, which is going to be gas to liquid. अगेन अगर बॉइलिंग के अंदर इंक्रीज इन टेम्परेचर था, तो कंडेंसेशन के अंदर डिक्रीज इन टेम्परेचर होगा. आप एक चाय का मग लाए हो, कॉफी मग है, इट्स वेरी हॉट राइट नाउ, राइट, एंड यू प्लेस अ लिड ऑन दैट हॉट टी और कॉफी मग. यू सी वाटर ड्रॉपलेट्स थोड़ी देर बाद अगर आप वो लिड हटाओगे, दैट इज ऑल्सो कंडेंसेशन. ठीक है, दिस इज वेयर यू हैव योर कॉफी मग राइट नाउ, and the moment you place a lid on that coffee mug and then you remove that lid, after a while you see कि यहाँ पे उस lid के top के ऊपर these are the water droplets. Why? क्योंकि ये अगर आपकी coffee है, this is where all of that gas evaporated first and converted back to liquid. पहले यहाँ पे उस मग में से evaporation हुई, liquid to gas, और फिर condensation जब ये gas दोबारा आपके liquid droplets में convert हो गई. So this is where evaporation take place, एंड देन कंडेंसेशन टुक प्लेस। मतलब एट दिस पार्ट ऑफ द मग जो कि हॉट था काफी, टेम्परेचर बढ़ा, इंक्रीज हुआ, कॉफी मग से कुछ कॉफी या वाटर ड्रॉपलेट्स evaporate हुए, turned into water vapors and then started to collect at the bottom of the lid। यहाँ पे टेम्परेचर डिक्रीज हुआ तो ऊपर जाते जाते उनकी एनर्जी लूज हो गई। बड़े ऊपर गए थे फुल गर्म होके एनर्जेटिक होके, जिन पार्टिकल्स ने वाटर वेपर के थ्रू लीव हुए सरफेस से, वही एनर्जी लूज करके जब थक गए, लिड के ऊपर दे फॉर्म्ड दोज वाटर ड्रॉपलेट्स। व्हाई? बिकॉज व्हेन अ गैस चेंजेस इनटू अ लिक्विड यूजुअली ऑन कूलिंग, ऑलवेज ऑन कूलिंग, व्हेन अ गैस इज कूल्ड पार्टिकल्स लूज एनर्जी। जब लूज कर जाते हैं दे अगेन बम्प इनटू ईच अदर बिकॉज दे लैक द एनर्जी। उनमें हिम्मत ही नहीं होती कि वो दोबारा एक दूसरे से बाउंस अवे हों और दूर जाएं टकरा के। दे स्टॉप रिफ्लेक्टिंग, इंस्टेड दे ग्रुप टुगेदर वंस अगेन टू फॉर्म लिक्विड। वो पार्टिकल्स जो गैस थे, इनमें एनर्जी कम होती है और ये एक दूसरे के करीब आ जाते हैं, वापस एनर्जी खत्म है। दे डोंट हैव एनी चॉइस अदर दैन टू रीग्रुप। एंड व्हेन दे रीग्रुप, उनमें दोबारा से डिस्टेंसेस कम हो जाते हैं, उनमें दोबारा से वो फोर्सेस ऑफ अट्रैक्शन एक दफा दोबारा आ जाएंगी। और आप इसको और फर्दर कूल करोगे अगर लिक्विड को, तो ये और करीब आ जाएंगे, इतना करीब दैट दे आर गोइंग टू बिकम टाइटली पैक्ड। So this is how we explain all of the state changes, gases to liquids to solids. So no energy is required for condensation to occur। ये भी एक range of temperatures के ऊपर it can easily take place. So does condensation only occurs when temperature is high? No. 90% of the times condensation only takes place when there's cooling। जैसे अगर आप बारिश के मौसम की बात कर लो, और when you talk about fog, fog होती है, और when you're traveling in winters on a motorway and you see on your car windscreen, that is also condensation। आपकी जो गाड़ी की windscreen के ऊपर जो fog आ जाती है, हम उसको fog कहते हैं, that is what basically, that is also condensation। अब वो तो ठंड में हो रहा है, राइट। और ऑल्सो बिकॉज इट्स अ रेंज ऑफ टेम्परेचर, आपके पास आउटसाइड कूल है, इनसाइड यू हैव अ हीटर ऑन, सो इट्स नॉट स्पेसिफिकली अ कंडेंसेशन पॉइंट। ये बात करना कि इट ओनली अकर्स एट कूल और इट ओनली अकर्स एट लोअर और हाई टेम्परेचर्स, दैट इज व्हाई देयर इज नो सच थिंग एज कंडेंसेशन पॉइंट। फ्रीजिंग पॉइंट एग्जिस्ट करता है, मेल्टिंग पॉइंट एग्जिस्ट करता है, बॉइलिंग पॉइंट एग्जिस्ट करता है, कंडेंसेशन पॉइंट इसलिए एग्जिस्ट नहीं करता क्योंकि कंडेंसेशन कैन हैपन ऑन अ वाइड रेंज ऑफ टेम्परेचर्स। एक चीज विच इज कॉमन टू कंडेंसेशन इज कि जब भी बस टेम्परेचर डिक्रीज होगा या पार्टिकल्स एनर्जी लूज करेंगे, दैट इज व्हेन कंडेंसेशन विल हैपन। सो आई होप दैट आंसर्स योर क्वेश्चन, मारुक। इज इट क्लियर एवरीवन? एवरीथिंग टिल नाउ, इज एवरीथिंग क्लियर? You guys can let me know so we can move on with sublimation as well. Good job, Anas. Thank you for your reply. All right. So can anyone tell me sublimation? Now, this would be a rather new term for most of you. What is sublimation? Any idea? Yes, Mirab, Noman, anyone who has an idea on what is sublimation and would like to answer and participate? Okay, I have a message here. Solid to gas directly. Thank you, Mirab. That is exactly correct. अब इसके examples के बारे में अगर बंदा सोचे, थोड़ा confusing होता है। Sublimation की क्या examples है? Directly कोई चीज solid to liquid जा रही है, ठीक है? Dry ice, if most of you have watched those, बहुत trending reels वगैरह होते हैं, people experimenting with dry ice। Dry ice क्या है? It also turns from solid to gas directly। फिर according to examiner mark schemes में solid to gas directly without being converted to liquid। Yes, Mirab, exactly, your answer is correct। सॉलिड टू गैस कन्वर्जन में ड्राई आइस आ जाता है। एक और एग्जांपल अगर हम लें, लेट्स से बारबेक्यू, मोस्ट ऑफ यू डन हैव बारबेक्यू, सबने किया हुआ है, राइट? बारबेक्यू के अंदर, नाउ डोंट मेंशन दिस एग्जांपल इन द पेपर, इट्स ओनली टू एक्सप्लेन यू गाइस, ठीक है? बारबेक्यू के अंदर जो कोल यूज होता है, ठीक है, कोयला, दैट इज ऑल्सो एन एग्जांपल ऑफ सब्लिमेशन, राइट? वी कॉल इट सॉलिड कार्बन। सॉलिड कार्बन आप मेंशन कर सकते हो पेपर में, लेकिन ये कोल या कोयला ने लिखा ना कि सर ने कहा था बारबेक्यू एग्जांपल है, वो एग्जांपल नहीं है। कोल किस चीज से बना हुआ है? सॉलिड कार्बन से। ये एग्जांपल हो सकती है सब्लिमेशन की। वो कोयला पानी तो नहीं बन रहा ना। इज देयर एनी पॉइंट, हैज एनीवन सीन कोल टर्न इनटू अ लिक्विड? वी हैवंट। वो डायरेक्टली किस चीज में कन्वर्ट हो रहा है? गैस, एश, सल्फर डाइऑक्साइड, ठीक है, कार्बन मोनोऑक्साइड, इन इन चीजों में कन्वर्ट हो रहा है। कार्बन डाइऑक्साइड गैसेस में डायरेक्टली कन्वर्ट हो रहा है, दैट सॉलिड कार्बन आफ्टर ऑक्सीडेशन एंड स्टफ। दैट इज ऑल्सो एन एग्जांपल ऑफ सब्लिमेशन। According to the examiner and your chemistry book as well, एक और example है that all of you might be experimenting in your labs one day or so other. Solid iodine. Solid iodine is also an example of sublimation. Solid iodine भी directly vapors में convert हो जाता है. It is an example of sublimation as well. Something that is not in your syllabus is the opposite of sublimation, which is desublimation. Desublimation होगा gas to solid. अब यहाँ पे in terms of आप सोचो kinetic theory में कोई चीज directly जो इतने particles जो close together थे, arranged regularly थे, they were so rigid and now they have completely gained so much energy that they lost all of their intermolecular forces of attraction. They all gained so much high speeds that they converted from solid directly into a gas. Now, this is only happening to a few solids such as iodine or solid carbon dioxide, and the reverse reaction also happens and is called sublimation. Is vapor deposition and desublimation the same? Exactly, Mirab. Vapor deposition and desublimation is the same, but the vapor deposition जो term होती है, that is mostly used in edexcel. ठीक है, edexcel जो students पढ़ते हैं, they are using the terms जैसे आपने previously भी एक mention की थी in terms of vapor and vapor deposition और सिर्फ deposition भी. ये जो terms है ना, these are used in edexcel iGCSE mostly. In O levels and Cambridge, we are still going to use the term sublimation and desublimation, but you are absolutely correct, no doubt in that. The reverse reaction, as Mirav has also just told me, is known as deposition or desublimation to be more specific. Vapor deposition as well, exactly, Mirav. Okay. Sublimation also occurs at a specific temperature which is unique for a pure substance. अब किसी भी टर्म हम आगे एक और जो हमारा नेक्स्ट चैप्टर है मेजरमेंट एंड प्योरिटी में एक सबसे पहला जो आंसर आता है हाउ डू यू नो अ सब्सटेंस इज प्योर प्योर का मतलब उसमें कोई इम्प्योरिटीज नहीं है व्हाट आर इम्प्योरिटीज एनीथिंग दैट शुडंट बी अ पार्ट ऑफ दैट मिक्सचर और कंपाउंड मिलावट जिसको हम कहते हैं मिलावट है इम्प्योरिटीज हैं किसी चीज में और उसको चेक करने के लिए भी स्टेट चेंजेस हेल्प अ लॉट हाउ डू यू नो कि वाटर प्योर है बॉयल करके चेक करो 100 पे हो रहा है या नहीं हो रहा बॉयल हाउ डू यू नो वाटर प्योर है आप फ्रीज करके चेक करो कि क्या वो 0 डिग्री सेल्सियस पे फ्रीज हो रहा है क्योंकि वेन एवर देर आर इम्प्योरिटीज इन एनीथिंग ये आप नोट कर लो हमेशा नोट इट डाउन एवरीवन दैट whenever there are any types of impurities in any substance impurities उस substance के साथ दो काम करेंगे हमेशा पहला काम उस substance का boiling point बढ़ा देंगे और उस substance का जो melting point है वो कम कर देंगे इम्प्योरिटीज जिस भी सब्सटेंस में होंगी उस सब्सटेंस का बॉइलिंग पॉइंट हमेशा बढ़ जाएगा मेल्टिंग पॉइंट हमेशा कम हो जाएगा फॉर एग्जांपल वाटर में को वाटर प्योर नहीं है वाटर के अंदर कोई और मिक्सचर है ग्रेवल सैंड है कोई NaCl है सॉल्ट है शुगर है कुछ ना कुछ ऐड हो गया वाटर के अंदर अब वाटर्स बॉइलिंग पॉइंट वुड ऑलवेज इंक्रीज टू आई गेस 104 टू 105 बढ़ जाएगा और जो मेल्टिंग पॉइंट हो जाएगा वाटर का वो हो जाएगा जी -3 या -2 डिग्री सेल्सियस तो देखो slightly decrease in the melting point and slightly increase in the boiling point is always going to be done by impurities whenever impurities are present. Yes, Maruk, I will repeat this question and you would write it as well, Maruk. Whenever any substance has impurities, I mentioned, and this is we are already going to study this in chapter number 2 as well. Don't worry, वहाँ पे ये in detail लिखा हुआ है. I'm just telling you right now. Impurities अगर किसी भी substance में होंगी, उस substance का boiling point will always increase and melting point will always decrease. For example, water. Water में अगर impurities होंगी तो water का boiling point 100 से शायद 104 या 105 हो जाए. या उसका मेल्टिंग पॉइंट 0 से कम हो जाए और कम हो जाए -2 या -3 तक आ जाए सो आई होप नाउ इट्स क्लियर मारुक ऑलराइट सो ओवरऑल दिस डायग्राम विल टेल यू अ समरी कि एज वी गो फ्रॉम सॉलिड्स टू लिक्विड्स टू गैसेस क्या हो रहा है इंक्रीज इन एनर्जी और फिर अगर आप यहाँ से आओ सॉलिड सॉरी गैस टू लिक्विड टू सॉलिड यहाँ पे क्या हो रहा है ओवरऑल एक डिक्रीज इन एनर्जी इन टर्म्स ऑफ काइनेटिक थ्योरी यू शुड नो हाउ टू एक्सप्लेन ईच ऑफ द स्टेट चेंज चाहे वो सॉलिड टू लिक्विड हो या लिक्विड टू गैस हो दैट्स गोइंग टू बी हैपन एंड यू विल प्रैक्टिस मोर डोंट वरी इंशाल्लाह व्हेन वी विल बी डूइंग दोस टॉपिकल पास्ट पेपर्स हम 10 इयर्स के टॉपिकल टच करेंगे ओनली देन विल मूव ऑन टू द नेक्स्ट चैप्टर तो वहां से ईच ऑफ योर क्वेरी will be cleared as well. You can see this arrow as well. Internal energy कहाँ increase हो रही है जब आप solid से gas की direction में जा रहे हो और internal energy decrease कहाँ हो रही है जहाँ आप gas to solid की direction में आ रहे हो. Got it? All right. Now you are all requested to rejoin the second link for the meeting, ठीक है? And then we'll watch a short video as well so the lecture doesn't get boring. और फिर हम एक और concept को भी discuss करेंगे, including the diffusion. ठीक है जी? Okay.